Hello, welcome to my Calculus and Vectors video portfolio. We're gonna see how this is gonna go. I have my phone precariously sitting atop about 10 binders, so just wish me luck, and I hope that disaster doesn't strike. I just wanted to take this video as an intro to vectors, just like a brief overview of the first unit. And I thought a good way to do that is just to give a simple definition of what a vector is. So a vector is a quantity with both magnitude and direction. So cool. What does that mean? So I think a good way to show what a vector is to first show what it is not. For example, say you traveled 30 meters. This is not a vector because it's just basically a number. It's just the magnitude. It's just saying that you went 30 meters. However, if you added 30 meters to the east, this would then be a vector because you're indicating both the magnitude as well as the direction, east. Say your car is traveling 50 kilometers an hour. This is, again, not a vector quantity because it is just indicating the magnitude. It's just saying you're going 50 kilometers an hour. However, again, if I say you're going 50 kilometers an hour forward, this would then be a vector quantity because you've indicated the direction as well. So when I was saying in the first example that you traveled 30 meters, this was not a vector as we established, and this was a vector. But this is also called something. It's called a scalar, which is basically just a quantity with just magnitude. It doesn't indicate a direction. And you'll often find that scalars and vectors have a lot in common, a lot of crossover with each other. So in this case, for the scalar, you would call this distance, or just represented by a d. And for the vector, you would call it displacement, or represented with a d with this little arrow symbol above it to indicate that it has a direction and that it is a vector. For our other example, we had, 50 kilometers an hour and 50 kilometers an hour forward, which is kind of a weird way to indicate kilometers an hour, but it's fine. So for the scalar version of this, you could just call it speed, and you can represent that with an s. And for the vector version, you could call it velocity. You're going to represent that with a v with that little arrow on top. So those are two examples of kind of complementary scalar and vectors. Now I want to talk about how you can represent vectors because there are several ways. So the first way to represent vectors is what I've already shown you, and it's just by using words and obviously a number. So if I was representing displacement, for example, I could say 40 meters and then indicate the direction here. And I could say that in a lot of ways. I could use like descriptive words like left, maybe up, or I could go a different route and I could use the compass bearing. So I could say south 45 degrees east. And with the compass bearing, we always want either south or north to come first. So you might be wondering what this south 45 degrees east would look like visually, and that's actually where the second way to represent vectors comes in, and that's using a diagram. Vectors are represented with a tail, a line, and a head. This is a head, think of it like an arrowhead, and the tail just being this little dot at the end. For the diagram, you want your length of this arrow to be proportional to the size of the vector. So for example, if I had 30 meters east and 5 meters north, I would represent the 30 meters east much longer than the 5 meters north, if that makes sense. Going back to my first example, if I wanted to represent this 40 meters south 45 degrees east, I would have to draw out like this little coordinate plane, and we start with the first direction that it gives us, south in this case. So that's north, not south. I'm going to start here, and I'm going to go 45 degrees towards east. So it's about 45 degrees. Not really, but you get the point. The third and final way to represent my vector is by using symbols. So say I was going 90 kilometers an hour southeast. I could represent that by, first of all, getting my direction. So I'm starting south and going east. And using a symbol for this, we know that this is velocity, so I'm going to represent that with a V, a little arrow on top to indicate that it's a vector. Another way you might see vectors represented using symbols is through points. So if this is point A and this is point B, this vector might be called AB. So now that we're talking about symbols, I wanted to pose a question of whether AB, vector AB, is equal to vector BA. Because it kind of seems like they would be, right? Because they're the same points, they're the same distance from each other. So if I draw A and B, this is from A to B, so that would be AB. And I'll draw the same thing here. B to A, I'd go this direction. So yeah, I can clearly see that A and B and A have the same magnitude, but we're forgetting about the other component of our vector, which is the direction. So vector AB does not equal vector BA. However, properties about opposite vectors that you can state confidently is that vector AB is equal to negative BA, because it's just flipping the direction 180 degrees. And you can also say that vector AB is equal to the magnitude of vector BA. These are just magnitude bars, which indicates that we're talking about specifically magnitude, not direction. So before I end this video, I want to talk one more time about the direction of vectors, and how you represent the direction of vectors. So again, you can represent it using your compass bearings. So we have north, east, south, and west. And say I had a vector here, I would represent this by saying it's north, because I want to start at either the north or the south. And then I'm gonna follow the vector. Imagine this is 40 degrees. I say 40 degrees, and that 40 degrees is in the direction of east. So that's how I'd say that. But you could represent vectors in terms of each other as well. Say this is A and this is B. You could name this vector in quite a few ways. You could say 50 degrees from vector A to B, or you could say vice versa, 50 degrees from B to A, or you could just say 50 degrees between A and B. But you can only name vectors in this way when they are tail to tail, meaning that their ends or their tails meet at a specific point. So for example, you couldn't notate this angle right here by using this method because they're tip to tail. The tip and the tail meet at this point. So keep that in mind. So that's my intro video on vectors, and my next one will be on the addition of vectors, so stay tuned.